My name is Roy van Rijn. I've got a blog. You can read some stuff about mutation testing, but generally does projects I like doing, weekly projects. And you can follow me on Twitter. Just if you like to talk, send me a tweet. If you don't like to talk, send me a direct message. I work for a small Dutch company called JPoint. We do contracting work. Not that interesting, but these are actually my two mutants. On the right, you have Lucas. On the left, we have Nora. So let's start with a show of hands. Just to get a feeling. Yeah, you got one. Awesome. So who here does unit testing? Yeah, almost everybody, right? Cool. That's good. Who here does TDD? Test? Less people, but actual TDD. Like I really mean it. Not a single line of code without a failing test first. Less hands. Still a couple. But even I don't do that. I know it's good, but just in some situations it's just easier to write some code and do the test afterwards. I do always test, but just not always before. Who else continuous integration? Almost everybody, right? Like things like SonarQube to test, to have a dashboard. And, who measures the code coverage? Almost everybody. Yeah, don't ruin it. Who here does mutation testing? One person. Awesome. So, but that's actually a good thing because I'm mostly going to be explaining the concept, and yeah, if nobody's using it, well, then you're at the right address. Still people coming in? Come on. So, unit testing. Quick recap. Why do we do it? It's to prove that your code actually works, right? You're typing your code, and you want to know if it works. You write a unit test. Most of the time, you can also fire up the application and go to the. Usually that takes too long. You want to immediately test the thing you just wrote. It also improves your code design. If a method is, well, hard to test, it's probably doing too much. You need to cut it up. If you're unable to test it, if you're unable to separate it, you probably have too much dependencies. Cut it up. So writing unit tests improves code design. You also get instant regression tests. Like you write a piece of code, you write your test. 1 week later, some beginner colleague starts editing the code, and the test fails. So we all know what happens next, right? He puts @ignore, and he comes to you and he asks, well, what assumptions did you make about the code, and how can we fix this? And you have regression. And well, yeah, I don't have to. I'm preaching to the choir. It has become mainstream the last 10 years. Almost everybody's writing unit tests now. It's not weird. So continuous integration, it's easy to automate your tests. Of course, you should do it on your own machine, but yeah, as a safety net, you still have the continuous integration server doing it for you. It holds the actual truth. Everybody has their own little truth, but there's one code repository, one version that's really. And that's the thing on the continuous integration server. And it's easy to collect statistics, right? If you measure your code coverage, you can see it grow or decline. So, now we've ended up with code coverage. I hate code coverage. So what's code coverage? In this example, we got a very simple method. The first line is partially covered by a test. So we probably have one test. It got a false. It went to the final line, which is properly tested. And the second red line, it wasn't covered. It wasn't touched by a test. So that's how you can read code coverage. Martin Fowler already said, if you do test coverage, you know one thing. You can find untested code. And that's actually true. If it's red, it isn't covered by any test. So yeah, that's what it's useful for. But as a statistic or as a quality target, it's pretty much useless. And I'll show why. Let's take a car, for example. I recently bought a new car. I went shopping. Well, the only thing I want is like a lot of horsepower, and it has to be a good looker. My wife wanted to know if the car was safe. I really don't care, but we have kids. So when you go to the dealer and you ask, oh, okay, is my car safe? And he tells you, well, we drove with it for like 10,000 kilometers, and we did 3 crash tests. That's not enough, right? That's what you get with code coverage. It says, yeah, we've done some tests. What's the outcome? Did it crash and obliterate, killing everyone? That's what you want to know. You don't want. That's the problem with code coverage. It only tells you the test you've done. Well, we've done some tests. Well, I'm not going to tell you exactly what happened, but okay. Who has seen tests or even written them? I've written them, no problem, without any verification. You're just writing your test and you're looking at the code coverage and it becomes green and you say, oh, okay, cool. And next week you look at the code. There's no assertion. How the heck did that happen? But, yeah, I've had that. Or you've got an annoying manager who says, well, you have to have 80% code coverage. We can't go into production if you don't have 80% code coverage. So people will just start faking it. Just write some reflection code, go through all the getters and setters, instant 20% extra. Awesome. Code coverage is easy. It's easy to fake code coverage. And at the moment that happens, it's pretty much useless, right? You have to write code, you have to write tests because you want to have tests. And also, yeah, like I said, 100% branch coverage proves absolutely nothing. Well, it proves one thing. It proves that you made the effort to actually make a test, basically. It tells you nothing about the quality and what's being asserted, absolutely nothing. So yeah, I'm not going to say it, well, okay. Q custodi ipsos custodes, something like that. I had never learned Latin, but who watches the watchman? So the watchmen are our test, obviously, but who watches over a test? It isn't code coverage. It's mutation testing. Mutation testing was proposed by Richard Lipton in 1971. He went on to become like one of the biggest people in computer science. He also won the Donald Knuth Prize in 2014, which is like the Nobel Prize for computer science. And he's currently solving things like P equals NP stuff, simple stuff. But for me, he's known by inventing mutation testing. And actually, that's you hear that a lot, right? Functional programming is hot. It was invented in 1970. Mutation testing is now, ooh, we can finally do this. It was 71. I don't know what they were doing in the 70s. Actually, I do, but that was a good time. So what is it? It's a better way to measure the quality of your tests. There was a surge of interest in the 80s, but it declined. Actually, about 5 years ago, only universities and thesis papers were being written about the subject. It isn't widely used. But yeah, it's time to revive that. There was one serious problem with mutation testing. That was performance. I'm saying was. We'll talk about that later, about how you can improve the performance and what the problem was. So, what is mutation testing? Well, what is a mutation? Mutation is a small change in your code base. So, for example, we have the that method. It has a larger than equals. The mutation we do, we change it into a larger than. What's the point? Okay. We create a mutant. So what is a mutant? You take your entire code base, all clauses. You do one little mutation, just like I showed. That's called a mutant. And it's just one mutation. And you do this a lot. You don't do this 1 or 2 or 3 times. You do it thousands of times. And you don't do it randomly. Some people think you do that randomly, but it's actually deterministic. So you set up some rules about the mutations you are going to do, and you create all possible mutations, permutations. After that, we run some tests, and we check the outcome. So what would be a possible outcome? Well, we killed the mutant. How do you kill a mutant? We have a red test. A test fails. And this actually proves something, because you've actually tested an assertion with this. You change something, you change some logic, and a test fails. So this proves you actually asserted this. You not only touched the code, you asserted this. So it's much more powerful than code coverage. So what else could happen? Well, it could be alive. It didn't trigger a failing test. So you got a problem. If that small mutation would make its way into the codebase, nobody would notice. If you had some typo or somebody breaking your assumptions, nobody would notice. There aren't any tests. There could be a timeout, because we're mutating code. If you're in a while loop and you flip the sign, you could end up in an endless loop. Yeah, that's a problem. But there's also a solution for that. First, you do the normal tests. You just record how long it takes. If it takes 2 seconds, or hopefully faster. The mutant takes like 5 seconds, you can kill it. It just takes too long, so you can kill it. Other outcomes are obviously you can run out of memory. The same reason you can go into an infinite loop. If it creates something, you can run out of memory. And there are also the other run error. I've never seen a run error in the tool I'm using. And there's also non-viable. That's usually a problem when a new Java version is released and they change the bytecode slightly. Some mutants are just not viable. It creates broken mutants. Who here has heard of fault injection? No, not a lot of people. Well, fault injection is basically the umbrella term. So with mutation testing, we mutate our code and we test our tests. And with fault injection, you just mutate. And probably you mutate your system and you check how your system reacts. So for example, you've probably heard of Chaos Monkey, the tool that randomly shuts down services and servers and just to see how it reacts in production, which is a great tool, but that's a great example of fault injection. Who here has heard of debugging? I had never heard of that, but he's a German, probably. Well, we both hate Germans, right? The guys who are doing TDD, do you often pair program? Probably, yeah. Do you also play ping pong? So if you play ping pong, you're pair programming, so you're both behind the laptop. First guy creates a failing test, hands over the laptop to the second guy. He creates the code to actually make the test green, and he creates a failing test himself. Then it goes back to the first guy, so that's why it's called ping pong. Debugging is kind of the same thing. This was used before code coverage was popular and even before unit tests were popular. It would usually be instigated by a manager. He would walk up to one programmer who would say, oh, come, what you're going to do, you are going to introduce 120 bugs into the system. Write them down so we can find them later, but you're going to do that. You're going to commit that, and we're going to tell the team. The team has to find all the bugs. So they got like a week or a day or a couple of hours to find the bugs. And, well, they find bugs and they find bugs and they write them down and they fix them. And in the end, they come back to you, the manager, and they say, oh, we found all 100 bugs. And he was like, I put 120 in there, so. The percentage of bugs that you didn't find is actually a good indication of how many bugs are still in your system. So this is an exercise I had never heard of it, but I don't think people are doing it anymore, but this was popular in the 80s. So now we know what mutation testing is. Everybody wants to use it, right? So we need some tooling. And we're at a Java conference, so we want Java tools. There have been a lot of frameworks, and as you can see, some of them are made at universities. It's it's a popular scientific thing to play around with, but not really, people aren't using it really. There are two that's called, the first called Major, it's at mutationtesting.org, is closed source, and PIT, ptest.org. The second one is absolutely my favorite, mainly because it's open source, it has much better documentation. Major just doesn't have that at the moment. So the rest of the slides, I will talk about PIT and how you can use PIT in your project. There are also other languages if you're a .NET developer or Haskell or Ruby. Oh, this one is also for Java, but mainly for JavaScript and Ruby. The ones in purple, pink, purple, those are still active. The others are pretty much inactive, haven't been updated since 2005, 2006. So, we want to start using this. What do you need to do? Well, the first thing you need to do is you have to have mutators. Mutators are classes that will mutate your code. They do that by using bytecode manipulation. So you don't have to do anything in the source code. It's just in memory. No mutated code is stored, so you don't have to be afraid of some mutants running amok and getting on your production. That won't happen. It's perfectly safe. And you get a test result, obviously. The same thing you get with test coverage. So an example of a mutator. This is a condition boundary mutator. So if you've got like one variable is larger than 20, it will take it to larger than equals. It will test that boundary to see if you have a test that actually looks for that boundary. It also does things like negate the propositions. So equals becomes not equals, less than becomes larger than equals, because that's the complete opposite. You can remove conditionals. So normally your code would have if A is equal to B, and it would just say if true. And there are many, many more. You've got mat, which replaces shifts and all kinds of stuff. And there are many more. There's like returning, just removing variables at all, just always returning null, or removing a void. This is actually the best one, I think, because people forget about void method calls because they're hard to test, right? If you want to test a method and it does a void call, you have nothing to assert. So you have to have a mock or something. It's easy to forget. And what PIT does, it just removes the entire call. Maybe you notice it. Hopefully you do. Well, some of these mutators are on default, and some are optional. You can configure that. So what's the reason mutation testing wasn't really used? And it's all based on speed. Because you're generating thousands of mutants, and you need to run your tests each and every time. That can quickly become a problem, right? And that's also why it was unacceptable in the 80s. It's very CPU intensive. But there are a lot of methods to speed it up, and that's actually a good thing. Let's do a small example. First of all, PIT uses code coverage. I told you it was crap, but actually, it does have a purpose. For example, if you have a particular line in your code, do you need to run all the tests, or just the 3 tests that actually cover that line? So that's what PIT does. It does one time on your normal code, it runs the code coverage. It records for each line which test actually hit that line. Those are the only tests you need to run if you mutate that line. So that greatly increases the speed. Let's do a simple example. We've got 100 classes. For each class, we made 10 unit tests. And one unit test, it's 2 milliseconds. So if we want to run all tests, we're done in 2 seconds. That's very fast. So total time, 2 seconds. Let's say we create 8 mutants for each class. So 100 classes, 8 mutants, 800 mutants. If we want to brute force that, it already takes 26 minutes and 40 seconds. If we want to, for each mutant, run all tests. That's not acceptable. But if you do it at a smart way, like PIT's using with code coverage, It only takes 800 mutants here times 10 test cases, because, well, we're assuming each class has 10 tests, so we're assuming that's about the amount of tests you need to run for each mutation, times the 2 milliseconds for one test. That ends up in 16 seconds. So that's acceptable, right? We can wait 16 seconds. And it's exponential. If we increase it, like not 100 classes, but 1,000 classes, everything would run in 20 seconds. If you do the brute force method, it would take 1 day, 20 hours, 26 minutes, 40 seconds. And with the smart method, it becomes slower. It's 2 minutes 40, but that's acceptable. Just grab a cup of coffee or something. Or don't do it on your local machine, just measure it on your continuous integration server. Do it during the nightly build if it becomes really slow. But so, some performance tips. First of all, make sure you write fast tests. We just saw an example. It's exponential when you're going to create the mutants, and that's a problem. So all your tests that you're using mutation testing, they need to be really short and really don't go setting up whole integration tests. You have to exclude them from PID. Maybe you want to write the integration tests, but use it for your unit tests only. If you're going to set up fake databases, connect to that, and just don't do that. And also use good separation of concerns. If you have like very small classes, which have very small tests, you only have to have, if you have like a really large method, then a lot of tests are needed for that method. And they all, for example, hit the first line. So if you mutate the first line, you have to run all those tests. If you cut it up into smaller methods, which have their own little tests, it's much faster. So cut it up. And there's also, this is pretty new in PID, there's the incremental analysis. It's still marked as experimental, but it keeps track of the changes in your code base. So if you run the mutation test, you only edit one file, create mutants only for that file. Don't create all mutants. That's pretty logical when you think about it. But so you can enable that and check that out. That should really improve performance a lot. So how about mocking? Well, that's no problem. Everything you're used to working with in your unit tests, it just works. Because when you start PID, you can say which classes need to be mutated. You don't want to mutate everything in Mockito, for example. You don't want to mutate Spring. You just want to mutate your own classes. But you can configure that. I'll show that in a minute. So how do you actually use it? Well, there's a standalone Java process. You can run it. So it's easy to integrate in whatever you want. There's an end task, a Maven plugin, a Gradle plugin as well. There's a SonarQube plugin. IDE support is rather poor. I've been told there's an IntelliJ plugin, but I couldn't install it in IntelliJ. It's probably based on an old version. And Eclipse, well, Eclipse just fires up the standalone, and then it opens a browser with the result. And it isn't that great. But basically, you don't need to run it from your IDE. If you have a Maven project, just use the Maven plugin. It's much easier. And that's actually, I'll talk about that later. So the standalone, it's just a Java call. As you can see, you can say which classes need to be mutated with a wildcard. And you can also say which tests need to be executed. So you can, for example, exclude your integration tests and just use the unit test. It also needs the source directory, and it needs to put the report somewhere. And that's basically it. So it's one command, and you're done. You'll get a report, just like code coverage. You just run it, you get a little report. So it's just as easy. So there's no excuse to not use it, right? In Maven, it's even easier. Just add this plugin, and you have the same parameters. You can say target classes and target tests, and you can run it as as mentioned below, but you can also just use it in your regular build. So let's just go into an example of how to use this, right? This is our use case. We have something, an item, and it's 17 zloty. If you buy 23 or more, all the items are discounted to 15. And also, if you have a coupon, it doesn't matter how many you buy, they are just 15 zloty. I wrote the code, which is perfect. It doesn't have any bugs. No, it really doesn't have any bugs. I'm not trying to trick you, because with mutation testing, we are not going to test the code. We are going to test our tests, right? You probably won't find any bugs in your code. You only find, just like code coverage won't tell you any bugs in your code. It will only tell you which tests are missing. That's the same with mutation testing. So yeah, we need to write our first test. So what can we do? We could buy one, and it should be 17 zloty. Cool. So we buy one, it's 17 zloty, and that's the branch coverage. So we've hit the first line, it was false. You've seen this example before. We have to create another test. So what can we do? We can buy enough to get a discount. That's like 100, because 23 times 15, if I buy 100, it's 1500. I can do that by head, from my head. So that's looking better, code coverage, we're almost done. We've hit the first line. We haven't actually tested the coupon bit yet, but we have tested both the return statements. So we're getting there, now we're just going to buy one with a coupon, so it's 15, right? Yeah, that's it. We're done. We have the code coverage, no problem. It's completely green. So that's when we're going to run pit. And this is actually the report you get from pit. It's not pretty. Actually, that's one of the major problems I have with pit. It's not pretty at all. It really needs some work. It's probably made by an engineer. You can tell, really. So what does it say? It did a conditional boundary mutator. We've seen that before. We can quickly go back. That's all the way back. Anyway, what the conditional boundary does, it takes the larger than and it turns it into larger than equals, and it turns it into a larger than. So it generated one mutant, and it killed 0. So there's one alive. And that's also what it says. One survived. And that's a problem. We need to test this, because yeah, that's plainly a missing test case. So what did I do? I made another test. I copied the one before. Amount 23, the quarter case, and it should be 345, right? Code coverage, still okay? Because yeah, it's crap. And pit now tells us it still survived. This actually happened to me when I was doing when I was making this presentation. I was like, I tested the boundary, right? What the fuck? And yeah, you got it. I copied the last test, and it actually still had the coupon set to true. So I wasn't actually testing the corner case, because it would still fall back to having a coupon. This actually happened to me. I was saved by mutation testing, even writing this stupidly simple example. And again, with code coverage, it's green, no problems. And with mutation testing, yeah, you can find the bugs in your test. So yeah, it's actually pretty powerful. And I wanted to do the code. I wanted to show you, but it broke. So I'm not able to show it, and that really bummed me out, but well. Maybe if I can fix it, I'll show it to you later. Or maybe I'll post a blog post about it. But that's really crappy. But So, we'll skip right to the summary. Mutation testing. You test your tests. You don't test your code, you test your tests. It's the same as code coverage. You can find bugs in your tests, not in your code, in your tests. Code coverage is just wrong. It gives you a false sense of security. It's easy to get a higher percentage. When you do branch coverage, it's a little bit harder to get 100%. But yeah, you can game code coverage. You can just call some random method and get it like 40, 50, 60% green and say, oh, okay, cool, without doing any assertions. That's impossible if you do mutation testing. The only way to get a green, a positive result in mutation testing is to write the fucking test. It's impossible to game this because you're actually testing the assumptions. That's really powerful. And it's just so easy. You add it to Maven, you press run, and you're done. It's just as simple as code coverage. So there's no excuse not to use mutation testing. And if more people start using it and contribute to it and maybe make a nice GUI, really, if you have like some skill in GUI, please help those guys out. Yeah, we need that. Questions, probably. Yeah.
You mentioned mocking, and I met a lot of tons of tests. I mean, tons of tests made by my colleagues that were testing the void method.
Yeah.
When I'm testing void method, I know that I have to very strictly verify the mock or some stuff that I'm providing to the method because that's the only way.
Yeah.
And is there a chance to use a pit just to toggle if the mock was used properly and verified?
Well, that's actually, mutation testing will tell you that the question was, if you're using like a framework like Mockito, and you're doing verifications on void methods, it will just remove the entire call. So if that mutant doesn't get slayed, you're not calling the verify. That's one of the best use cases you have for mutation testing, which is something you can't do with code coverage. Code coverage will always be green if a void method is touched. It's instantly 100% green. It's perfect. Mutation testing, the only way to get it green is to actually verify it and have a failing test case in the scenario it's removed. So that's actually pretty powerful, yeah. Other questions? Yep.
So I'm a little bit concerned about the mutators. So you mentioned that there are these boundaries mutation, but and also we can remove the codes.
Mm-hmm.
But in, let's say, modern-ish codes, we don't have many ifs, we don't have many loops, we have method calls and
Lambdas.
this kind of stuff. So can it actually replace, for instance, a method call with another method call that would be compatible concerning the arguments or something like that? Because this can happen.
Yeah. No, basically, one of the most powerful things is just removal. Like I said before, if you remove it and a test doesn't fail, you're probably not testing it properly.
Well, that's not enough, right? Because you can remove something that will cause a different side effect than just calling something else, right?
Yeah. It causes a different side effect, but yeah, you're interested in the fact there's actually a test that notices the change. The change itself.
My test would fail if I just removed the call, but if I just call something else, I would treat the test. So
I think you don't have to remove the whole code. You can produce this other mutator that just changes the return value.
Yeah.
Right? And the result of the code.
Yeah, I didn't show all the mutators. There are a lot of mutators. So just give it a go. Even if
So the trick would be to mutate the code, right? Not the method I'm trying to
test.
But the code is being called inside.
Yeah, but that's also being mutated, and that's also being covered by tests, and even indirectly. Yeah. You had a question, yeah.
Did you ever run into meaningless mutants?
There are. Well, yeah, basically, if there is a meaningless mutant, then it's a meaningless piece of code, right? The code is there to do something. If you can change it and it doesn't affect your system, just remove it. Then it's basically rubbish. There are examples like logging frameworks. I don't want to test if I call my logging framework. So these are actually, I didn't notice, I didn't tell you that, but you can actually say, for example, all my calls to SLF4j, ignore them. I don't want it to fail on a logging framework because I don't want to write tests that I'm actually logging something. That's bullshit, right? That's logging. That's not part of your use case. Other questions? Oh, there are a couple on this side.
Is any good at mutating streams?
Yeah, I was thinking about streams. I've never used it in an actual functional project yet. But if you're like streaming, and using the dot annotation, I'm not sure. Yeah, it's always better than nothing. Like it's always better than code coverage. But I'm not sure. I'm not sure how it works if you're chaining methods. So I don't know. Maybe there's a mutator that just removes one chain because it's still a method call. But I'm not sure. I'm not sure on that. That was actually I was thinking about that. I haven't, but just give it a go. It should work. It should work with Scala, and it should work with basically with every JVM language because it does it on bytecode. But it also uses your source code to tell you which line it actually was. So it might break at that point, but I'm not sure. Maybe it works. I haven't checked, but that would actually be very useful to have. I haven't been so lucky to do a Scala project recently. My colleagues have. I'll ask them. I haven't, but there are mutation frameworks for JavaScript. Yeah, you can. There are even people writing them right now. In JavaScript, it's so flexible. You can write your own mutation framework in like a couple of lines. Yeah, of course, you need to have a manifest. You can't do anything in JavaScript without a manifest, right? Yeah. But no, I haven't actually used JavaScript yet, but try it, give a talk, use it. Yep.
To be 100% sure that you have all tests right, you have to implement all mutators, all places that could be potentially.
Yeah, and that's actually the problem. If you want to be absolutely sure, but you'll never be absolutely sure, you have to have a lot of mutators, and that would make your project slower. And yeah, that's yeah. There's always a cost involved. So.
What about multi-thread run of tests in such case?
What?
Can the mutators be multi-threaded?
That's actually a good point. And that's actually, if you have tests that actually call your code and they verify. For example, you raised your hand when you said, I'm like doing actual TDD, I never write anything. When you write a synchronized block, do you actually have a test that fails if I remove the synchronized block?
Actually, I'm not writing multi-thread code.
Okay.
I'm thinking more about running mutated tests in parallel.
Yeah. That actually happens as well. You can do parallel execution, but writing code for like removal of synchronized blocks, that's also a mutator, remove synchronized. But yeah, that basically means you have to have a test that fails if I remove your synchronize. And that's one thing. When I do TDD or try to do TDD, that's the point where I usually fail. Like I have to simulate a race condition in my test to always fail if I remove the synchronized block. I don't even know how you do TDD when you write code like that. But if you have those tests, it will work fine. It would find that you remove the synchronized block, but for example, or volatile, or So it all depends on your test and the mutators, but the mutators are there. So, other questions? Yeah, no, go ahead.
So are there some mutators for constants?
Obviously, yeah. There are mutators for constants, so the final static int.
Can you actually implement your own mutators? Is it easy, hard?
I haven't tried it yet, but because there are like really a lot. But let's just open it. They've got like this is the website. Oh, sorry. It's like, which side are you? Oh, that side. Awesome. Quick start. Where's available mutation operations? So there's like, it's a pretty big list. So you can see some are deactivated by default and some are activated by default. This was the void method call I was talking about. There aren't really that many. I thought there were more, but maybe below. No, so this is what they currently have, but
Happen to you to have problem with false positives like the loggers issue you mentioned? Because I believe that, well, if you have 100% coverage, perfect, almost perfect unit test, then this will be good for you. But let's say you don't really aim that high. You want to have coverage like 70% and cover the critical cases. So
yeah.
in this case,
But the report you end up with, is very much like code coverage. So it will still tell you, it will show you your code, and it will tell you for each line if a mutation was killed or still alive afterwards. So unless you call every red line in code coverage a false positive, which it basically is, so but just give it a go, try it. I'm pretty sure you'll like it.
So what I'm asking about is, did you find your way to distinguish between, let's call it, important or critical
Yeah.
mutants and those
I-
not really significant?
I get that question a lot when I do the presentation. So what percentage should I strive for? But it all depends on your situation, right? Yeah, when you're writing tests, when do you stop writing tests? When it's good enough? Yeah, it's easy to say you should always aim for 100%, right? But that's not viable in most situations. If it's good enough and it runs in production and you don't encounter too many bugs, you're probably doing enough testing. But yeah,
My concern is you don't really know if the mutants he found or that stayed alive are something really critical, because it might be, or they might be trivial like that.
no, you have to look at the results.
So you just need to manually.
Yeah. It's just like code coverage. If a part of your code is red, you have to look at it, and you have to look at do I really need a test for this, or is it okay? It's trivial. I've read it. But yeah, it's basically the same thing as code coverage. It's not something magical, and it doesn't solve all your problems. It's just code coverage, but a little bit better and slower. Yeah, that's it. More questions? Okay, thank you.